Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. We are on a most excellent series, one of a kind, zero to hero series on MicroPython using Raspberry Pico. Alright guys, let's take a look at it where we are. We are on lesson number 11 and I am going to show you how to operate your Pico in a headless mode. So what is headless mode? That means once you write your program using MicroPython, once you do the coding, you load it into the Raspberry Pi Pico, but so far you had seen all the exercise, you had been using the USB connected to your computer, right? And that's where it was taking the power. Now what we are going to do is we are going to disconnect that. After loading the program, we are going to disconnect the USB and connect the battery and how to power up your project. So basically I will show you how to operate Pico using a battery, right? In future lessons, we will be building several projects which needs to be operated through battery only. All right. For example, a small, robotic projects or a IoT device, IoT project, which I'll be showing you how to build using different types of sensors and motors, servos, DC motors and stuff like that. All those lessons are going to come in one by one. If you want to run your Pico without being attached to a computer, you need to use either a USB power to the battery or you need to use a battery to the GPIO pin, positive and negative, right? The most safe operating voltage, keep a note of this guys, it's very important. It has to be between 1.8 volt to 5.5 volt maximum, right? If you are using a heavy duty DC motor, I will show you in the future lesson, you will have to give an external power to the motor driver and operate for your robotic projects, which is pretty later stage. For now, let's make sure that you understand this. The operating voltage using the pins directly is between from 1.8 volt to 5.5 volt DC only. Now, in order to run the MicroPython program automatically within the Pico, you need to save it to the device as main.py. Keep a note of it when you are saving it from your Thonny IDE, which I showed you in the previous lessons. We used to save it as a blink and all those different names. But to operate your Pico headless mode using a battery, you need to save the program as main.py. That is how your system, the microcontroller, detects automatically when the battery is connected. In Thonny, basically, you need to click on the file menu and then save as for the last program you wrote. And it will show a pop-up saying that you want to save it in your computer or a MicroPython device. So you need to save it on a MicroPython device, which is your Pico, right? So let's take a quick look, guys, what we are going to do. So I'll show you. So let's go back to one of our previous lessons which we did. We connected a LED with a current limiting resistor. You can take 330 ohms or 10 ohms or any of the resistor which can basically limit the current, and go ahead with the LED and connect it as per this circuit drawing. All right, so make sure that it is one of the previous project actually we did. I think it was in lesson number 5 or 6, I don't remember. And most important aspect is the pin diagram, right? So this diagram I shared with you in one of the earlier lesson. You need to refer to this, guys, very important. So for example, if you go by pin number 1 here, which is written as 1 2 3 4, that is actually not a pin number 1 2 3 4. You should not get confused, right? That is just the nomenclature, because there are 40 pins. The first row is 20 pin and the second row is another 20 pin, right? But basically the pin number 1, what is written here, it's actually GP0. Can you see all these green marks? So that is what we will be referring in the Python program, in the MicroPython code. When you give a command as an output or an input from the sensor, you need to use this pin numbers, pin 0, GP0, GP1, 2, 3. So basically GP4 is the physical pin 6. Say GP5 is physical pin 7. Same way, say GP14 is physical pin 39. Pin GP15 is physical pin 20, right? And same way here on the green, can you see? The GP28 is basically physical pin 34, right? Same way all these green ones, and the black ones are the ground. There are four, this side four, another side four. There are 8 ground pins, so that's a negative terminal of your battery. And to look at the power, there are 3 indications here. So majority of the time we'll be using pin number 39, right? This one, so which is written as VSYS. So that is what the power which takes between 2.8 volt to 5.5 volt. So that is the sorry, 1.8 volt to 2. What was that? I forgot. Let's look at what was the actual voltage. I think it was 1.8 volt to 5.5 volt. Yes, correct, 1.8 to 5.5 volt. So that is exactly your pin drawing takes. To look into more details, let me share you another drawing. So this makes it more simple when you are using Pico for any of the headless mode project for robotics or IoT applications connecting to the battery. So you can use this drawing. Always use this pin, which is actually pin number 39, okay, which is 2 volt. It's written 2 to 5. It's actually 1.8 volt to 5 volt DC external power, which is written here, right? Or if you are using your battery connected to the micro USB port, that there is a plug which is available, right, which is a converter. So you can use that as well, so that you can directly plug in here. So that makes more easy. But for prototyping and PCB soldering and kind of thing, I think the ideal way is to use the pins, these pins. So keep a note of it, guys, and that's what we are going to do in this particular circuit. So what we are going to do is basically, once you build the circuit, we are going to power up the positive terminal in pin number 39. Okay, so pin number 39 is what? If you look at the architecture here, this is the 39, and 39 is red, and what is written here in red? It is power. Even this is power, 3.3 volt out, which is written pin number 36. That is also a power. Pin number 40, that is also a power. But ideal way to use it is next to the ground pin. It's easy for the circuitry and stuff like that. All right, now let's write a simple code to blink this LED, and let's see what happens. I am connected to my Thonny, and I had already connected my Pico to the USB port of the computer. Now let's move on. Let's write some simple code and make the LED blink with a battery. All right, guys. So let me open it up. So open up the fresh. I hope I'm sharing the IDE with you. All right. Great. Now let's do one thing. Open a new file in the IDE. It is written as untitled, so leave it as it is. Don't do anything right now. You just write the code to blink the LED. So what we need to do, we need to use the machine. From machine import pin. P should be in uppercase always. Okay, import pin and timer. All right, once you put in that, then we need to say our LED equals to pin number 15, which was connected to 15. Now how do you know it is pin number 15? So let's go back to the architecture, right? So if you see here, 11, 12, 13, 14, 15, okay, here pin number 15, but it's actually in physical pin number 20. So do not get confused. It's actually the green ones which you need to refer, the GP pins, the GPIO pins. That's what we will be using most of the time. 80 to 90% of the project will be using only these green pins, unless until we are doing some remote control activities and projects and stuff, which is going to be at a later stage. We will be accessing other pins as well. I'll show you step by step. So for now, GP pin, right? This is the pin as per this circuit. If you look at this particular circuit drawing, you will understand where the resistor is connected to the LED. So that is pin number GP15, which is your physical pin 20. I hope this is clear, guys. If you have any doubt, do message me. I'll be happy to explain to you one-on-one on the Zoom. All right, let's get back to Thonny. Now pin number 15. All right, so let's declare this as pin number 15, and then I will say pin dot out. I am sending out the signal, and I am setting the timer. Oops, it has to be in uppercase. Timer equal to timer in uppercase T, and close the function parenthesis. And then we need to define the blink. Def, define a class called blink, and we will say timer. Okay, and colon. As soon as you hit enter, the indentation automatically comes below the blink. LED dot toggle function. I hope you understand the toggle function which I explained earlier. And then go back here to the main grid below below the def. We need to say timer dot init with the frequency of 2.5 milliseconds. All right, and then the mode equals to timer dot periodic. Timer dot periodic should be all in uppercase. All right, periodic comma callback function equal to blink. We are going to call back the same function to blink with the timer function. All right, now what we need to do, I hope it works. Let me just give a space here. Okay, now what we need to do, you need to go to file, click on file and save as. As soon as I click save as, okay, it's gonna show me, no, I think I need to run it first. If I click run, it's going to ask me to save. Obviously click the run button, the green, okay guys, green button. Okay, now it's asking me to the pop-up message. I'm able to see the pop-up message. You may not be able to see. The pop-up message says this computer or Raspberry Pi Pico. So I'm going to click Raspberry Pi Pico, and I'm going to save this as main.py. All right, make note guys, this has to be main.py. Main.py. All right, main.py. Now I'm running this program. There you go, my program is working perfect. Let me just share the circuit. Where is the video? Okay, let me share it here. So if you see my breadboard, I have already connected and the LED is glowing as per this particular program. Okay, I am not connected to battery, I kept it separate. By the way guys, you can go ahead and pick up this particular battery. It's a 8650 rechargeable battery, and it's very easy to maintain. It's 3.7 volt, and you will get it along with the holder and this kind of jack. Okay, this is the most convenient way to operate your Raspberry Pi Pico with headless mode on a battery. All right guys, now what we need to do, I'm going to disconnect the USB. You can see it here. I'm going to disconnect. All right, it's disconnected. Now it's totally off. Now I have given the power supply to the positive terminal, and the rest of the circuit is same. The ground pins are same as per the circuit drawing. Only difference is I give the power here. Can you see there's another jack? There is another jack point where the positive terminal goes as per the architecture drawing. So if you go to the architectural drawing, let me just open it up here in pin number 39, right, which says VSYS, that is the red, and that is where I had connected. Can you see it here? Let me just share it again. So that's the pin number here, pin number, from the top, from pin number 39. Now let me just plug in the battery guys. I hope it works. All right, there you go. The LED works perfect. But some loose connection probably. Yeah, there you go. Can you see it? Now we are on a totally headless mode. So now it's 100% confirmed that we can operate our Pico totally headless mode using just a 3.7 volt battery. We are going to do ton loads of exercise using the same setup with a 3.7 volt battery, 8650 rechargeable battery, and in the upcoming lessons. But when we get into the motor aspects, we will, because we'll be connecting multiple other devices to drive the motors, so we may need extra power. So I'm going to show you how to build that particular circuit. All right guys, have fun, do build it. If you have any questions, if you have any doubt, do reach me out, do leave a message. I'll be happy to explain to you. Bye bye.